back to my channel, and today we will be discussing about Fibonacci series. And so we are talking about recurrence relations, and we will talk about where we can find more examples in real world where the recurrence relation used to solve that problem is that of a Fibonacci series. Okay, so let's get started. So first, I will tell you about the recurrence relation. What is recurrence relation? Recurrence relation means you have a big problem. Okay, a problem of uh, okay. We will start with the Fibonacci series only. Okay, the zeroth term of this series is 1. The first term of this series is 1. The second term of this series is 2. The third term of this series, 2 plus 1, means you are finding the next term uh, of the series by adding the previous two terms. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. And so on. So this whole series, if I want to generate the terms of this series and any nth term of this series, any nth term an can be found out by summing two smaller problems, the n minus 1th term plus the n minus 2th term. So you are taking two smaller problems of n minus 1 and n minus 2 size, and when you combine the answers, you get the nth term or the answer to the bigger problem. So this is the recurrence relation. Getting the solution for a bigger input size using the answers calculated for smaller problems. Okay. So this is how mathematically Fibonacci series is defined. But how, let us talk about in real world how Fibonacci series was identified. It was by studying the growth pattern of rabbits. Growth pattern of rabbits every month. Okay. So in the beginning at month 0, what happened? We took a pair of rabbits. So the rule is that after the rabbits become 2 months old, they start reproducing. Okay. So we initially had a pair of rabbits. Let us term as R1. R1 is a pair of rabbits, but right now there are 0 month old. So it will not reproduce. At month 1, it becomes 1 month old. So still we have, so at month 0, we have one couple of rabbits. So we have one couple of rabbits. At the end of month 1, we still have one couple of rabbits. Then at month 2, at the end of month 2, what will happen? Now this R1 couple, they became 2 months old, right? 2 month old, so it will reproduce. So we will have two couples, R1, this couple, as well as a new couple, R2. Now this R2 is 0 month old, so it will not reproduce. So we have two pair of rabbits. Okay. Then at month 3, what will happen? At the end of month 3, what will happen? We will have R1 as it is, R1, right? It will R1, R2 as it is will be there. R2 will become 1 month old, right? But it will not reproduce. But R1 is already 2 months old, so it will be reproducing another couple R3. So we have at the end of month 3, we have 2 plus 1. We have 3 pair of couple of rabbits. What happens at the end of month 4? Month 4, we will have R1 will be as it is, R2 will be as it is, R3 as it is. Now, who became 2-month old? See, R2 has become 2-month old. So R1 was already 2-month old, so it will produce a pair R4. R2 will also reproduce now R5, and but R3 will not reproduce. So we have 1, 2, 3, 4, 5 pair of rabbits, right? So we will write it like this. So we had 1, 1, 2, 3, and 5 couple of rabbits, right? So observe the pattern. So what Fibonacci did was he observed, right? So suppose at the end of month 3, how many couple of rabbits uh, we will get? How he identified? Note that the rabbit who is present 1 month before, right? This is month 3. So before 2 months before month 3, 1 month, 2 month, 2 month before month 3, it will be definitely 2-month old at R3. So definitely it will reproduce. So R1 will be added twice. Okay. Then but the couple who are present only 1 month before, they will not reproduce, right? So that will be added only once. So again I will be telling the couples. So here only R1 was present 2 months before this month 3. Only R1 was present, right? So R1 will be reproducing. So R1 pair will be added twice, right? And the number of couple of rabbits who were present to just 1 month before, they will not be reproducing, they will be added only once. So if we add the number of couples which are present month 2 months before this month, you get the actual number of rabbits that will be present at month 3. Again, if you check at month 4, how many rabbit couples were present at 2 months before month 4? That is month 2. So I will change the color. At month 2, we had two rabbit pairs. So these two rabbits will reproduce at month 4, right? So R1 and R2, R1 and R2 will be having to be added twice. So I know R1, R2, R1, R2 is present at month 2 as well as at month 3. So if we add these two, so R1, R2 and R1, R2's offsprings are added. But the pair that is present only 1 month before R4, they will not reproduce. They are not old enough, right? So 1, 2, 3, 4, 5. So this is how he observed that why the previous two terms has to be added to create the recurrence relation for Fibonacci as sum of two previous terms. I hope you understood this. Now we will look at another problem, real world problem that is solved using the recurrence relation of Fibonacci, but on looking at it you will not be able to understand it's a Fibonacci series problem. Okay, suppose you have to find the number of ways you can climb stairs. Okay, you can climb the stairs. Okay, you have n stairs like this. You have n stairs. Okay, and you can take one step at a time. Either you can take one step at a time like this, or you can take two steps at a time, or you can take two steps directly like this. So in how many ways can you complete climbing n stairs? That is the question. And this question is also solved using Fibonacci series. How? Let us see. Okay. So how will you solve this? Okay. Suppose this, we know, okay, suppose We know in how many ways we can climb n minus 1 stairs. Okay, we already know this, suppose. Okay, and if you take one more step, you reach the nth stair. So this big problem of climbing n stairs can be solved if you know the answer how to reach till n minus 1th stair and then take one step. Okay, so the ways to solve to climb n stairs is equal to the ways you can solve the you can climb n minus 1 stair into one step plus any other way to do this. Yes, uh, we will erase this. Okay, another could be you know the how to suppose you already know how number of ways you can climb till n minus 2 stairs. Okay, till n minus 2 stairs how you can climb you already know. Now you just take two steps. Okay, so 1 into the number of ways you can climb n minus 2 steps. So see, this is also the recurrence relation for Fibonacci series. The bigger nth problem is solved using the answer of n minus 1, a problem of size n minus 1 and a problem of size n minus 2. Okay, and then again we will see another problem. Another problem is, this problem is also solved using Fibonacci's recurrence relation. Okay, suppose you have n bits. Okay, you have n bits. These are n bits, and you have to find how many strings you can make using zeros and ones. In all these blank spaces, you can fill either 0 or 1. Okay, and such that no consecutive zeros should be present. You cannot fill consecutive zeros in any of the blanks. In how many ways you can do this? Okay, so how many ways can you do this? Okay, so suppose your string, it can either start with 1. If it starts with 1, then the remaining n minus 1 bits, if you know the how many ways you can create n minus 1 bit strings which has no consecutive zeros, just append 1, then that will be a solution to the n bit string. Okay, that is one way. That is, n bits an is equal to append one way into the number of ways you can find. You can form strings with no consecutive zeros using n minus 1 bits plus. Now what if your bit is starting with 0? If your bit starts with, if your number n bit string starts with 0, the next number, it cannot be a 0. So it is fixed, it has to be a 1. So apart from this 0 and 1, remaining n minus 2 bits, how many ways you can form such strings that does not have two consecutive zeros? So 1, that is, we will append 0 and 1 to all such n minus 2 bit sized strings. Okay, so this is also the example of the Fibonacci series recurrence relation. So hope you like this video. Please share it with your friends, subscribe to my channel and stay tuned for more discrete math videos. Bye bye, take care.